Okay, Paolo, over to you. You have an announcement about the new era of the graph.
Yes, hi everyone. Yes, so I wanted just to, to share just an update that, after yesterday announcement. So I can also share maybe my screen. Let me see. Okay, I want just to share my screen if I found, okay, that's one. I think you can see now it's just, just a slide. So yesterday we announced the new era of the graph. So we have a new landing page on the graph.com/roadmap. And from this page, so you can see the 5 pillars of the new roadmap. So basically the world of data services, the developer empowerment, optimized indexer performance, interconnected graph of data, and protocol evolution and resiliency. So, we all know that a lot of people are still referencing the graph as the Google blockchain, but this is actually not true anymore because on this new, roadmap, so we want to move beyond, subgraphs. So basically, this is a new long-term roadmap to serve all the different data and different user needs. So basically, there are three main points also. So this new roadmap will culminate basically in serving not only the classical on-chain data, but also to support more query language like SQL or LLM, and also around verifiable data. So this is really something very exciting for the future for the graph. And so it's just to invite everyone to have a look on this new landing page and to have a look on these 5 pillars. So for example, one of these, so that probably we know already because we are talking a lot about this in the forum already, the world of data services, that we know that subgraphs are now becoming the standard to access blockchain data. And now thanks also to all the technology built by Streaming Fast, thanks to Fyros and Substream, so we can also extract data much more faster and also transform data more faster, and also query in the future not only with GraphQL but also with SQL and with also natural languages. So this is very interesting, and also the ability to serve other data rather than on-chain data. And together with this, so we have also a lot of developer empowerment. So we already know that we want to, improve the user experience also from developer point of view. So we are already, for example, transitioning to Arbitrum. This is, a long-term project. So it's also about this pillar about improving the new billing system, and to also here there is another initiative that is an initiative on its own, the Sunrise of Decentralized Data, to ensure that all the subgraph on the hoster service will migrate seamlessly to the decentralized network, and around also improvement on GraphQL API. And so another pillar is also this one is pretty big one. The protocol evolution is around a new initiative that is called Graph Horizon. There are also more information on the public forum. So about transitioning the protocol to even a more permissionless way, because today, so we have still some, let's say, centralized points, and so we want further to push for decentralization and the permissionless of the protocol. And also the fourth pillar is also something that you know very well also here, because it's about the indexer performance, and also providing a scale indexer stack. So this is of course your field, and where you are talking weekly. And yeah, and also the fifth pillar is about interconnected graph of data, so to provide also user application also to make sure that we go from data to information in a human curated way. For example, this is something that the Geo browser is working on. So this is the new era of the graph, so 5 pillar, and is I just wanted to invite everyone here to when you have some time, to have a look on the new roadmap, and to provide also feedback. Also, we have also the public forum, so we are always open for feedback. So that's my update. Thank you.
Thank you very much, Paolo. Please post any questions if you have any in the chat. Okay, if not, I will get ready to share my screen and start today's LOH. All right. You can you see my screen well? Yes. Okay. Okay. So welcome to today's LOH. So today's 8th of November 2023. On the agenda today, we'll start again like we always do with the latest Launchpad development since last LOH. Then we have two demos for you. So one that dives more into storage and using and deploying custom storage classes. And then we also have a demo around ingress resources and how to customize your ingress in your cluster based on using the ingress namespace. And then we have open discussion. So in terms of update from since last LOH, we have released new stable releases of Launchpad charts for pretty much all of the charts that we have. That's for tracking dependencies updates automatically. And we have also added quite a few updates to Launchpad namespaces. So we have added Sepolia support for Ethereum namespace. We have added subgraph radio feature that is enabled by default, and Arbitrum flavors to graph namespace. And we have released a bunch of stable update versions of storage, monitoring, sealed secrets, Postgre operator, and so on. In terms of documentation, we have updated the FAQ from the previous LOH, and we have added instructions on how to change the cluster config for a live cluster using kubadmin. So say you need an update to how etcd works or an additional flag, we have added instructions on how to do that on the docs. Now the next thing would be jumping into the storage part of the demo, but I just want to quickly touch upon K9s. Just one sec. All right, so so we have a one. Let me just clear this. So we have a for today's demo we have a one node cluster that has been created with kubadmin using the guide on the docs. This is running on Ubuntu and running version 1.28.3, and that's what we'll be using for today's demo. And I just want to show really quick before we start installing anything. And yes. Thank you for that. I thought I was sharing the whole screen. Okay. All right. So you can see my terminal now. Yeah. So for today's demo, we have installed Kubernetes cluster on one node using kubadmin guide that exists on the docs. And it's the same demo that Carlos did last week. So we've already done that for today's demo, running 128.3 Kubernetes version and quickly wanted to show in K9S some of the components that it comes with. So you can see in the Kube system namespace, which is the namespace managed by Kube admin, you can see all of the different components. You have etcd, the key value pair for everything that happens into the cluster. You have the API server, controller manager, and scheduler. And then we also have Cilium that is used as a CNI. And that's pretty much what the cluster has inside. I'm just going to take a second here and say that you can use K9S for pretty much for querying all of your Kubernetes resources. And one way to do this, to find out its cheat sheet, is by running question mark. That shows you all of the different commands that you can run here. Escaping to go back. If I want to see a specific type of resource, I usually run shift colon. So say I want to see all of the services. You can see all of the services running. You can switch between all namespaces and default by using 0, 1, and so on. If you want to go back to pods, and if I want to look at some logs, that's just a matter of pressing L. Sometimes you see this waiting for logs, but there's different ways you can see log content. So for example, if you want to see them from 30 minutes ago, you can run 5. If you want to see tail and head and so on. Another thing that's super useful here, you can describe a pod so you can see events. So sometimes a pod is in a certain state, say it's pending or it's crashing. It's useful to describe it, and then you'd see the events here that gives you more details about what's happening. And similarly, with pods or any other resources, you can press on Y, which is the YAML, the whole YAML definition for the resource. You can also port forward and attach to a container, but we'll show that later on. And with that, if you're ready, Carlos, we can talk about storage.
Yes.
Would you like me to show that diagram first?
Yeah, we can start there. I think just a quick review about this abstraction, which maybe not everyone is familiar with, but Kubernetes implements this abstraction of PVCs and physical volumes and physical volume claims, which is just basically the workloads that run on pods, containers, attached to a PVC, the container storage, which has an API and defines kind of an object that defines a bunch of parameters. Those claims then get tied to a physical volume. And then there's like a driver that takes care of actually doing the operational workloads of provisioning those physical volumes and managing them. And there is a very vast array of drivers that you can use. They're called like container storage interfaces. Today we're going to like Launchpad comes by default with a local PV raw file, which is just local storage on your disk based on files. I'll go a bit more into it in a bit. We're also going to show ZFS local PV, which is also node local storage, not network available storage, but the backend will be based on ZFS. Oops. And this is kind of a very general pattern in Kubernetes, where you have these abstractions that create objects, and the workloads consume those objects. But then there's like the implementation is left, to external drivers, and there's always many available, or sometimes a lot of them available. This is kind of a general pattern that you get everywhere. When Anna is going to be talking about ingress later, again, there will be an ingress definition, like an API for ingresses, and there's like this object. And it's very common that people use nginx to be an ingress controller or to be in charge of actually implementing what's intended from that API. But there are more alternatives. HA proxy is another example, and there are other workloads that there are other options or drivers that would serve as an ingress controller. So there's a lot of external things you can fit your cluster with, and it's very customizable and very extensible. I don't know if anyone has any questions about this, or you can just start with Launchpad and deploying. I'm going to share my screen. I think it's working, I hope.
Yeah, we can see your Discord.
Okay. So last time we did a cluster deployment, and we kind of left off with just a cluster in Cilium. Back there, it was a multi-node cluster and so on. But now we just have a single node cluster. That's enough for our purposes, which is to pick it up from where we left and just start deploying things with Launchpad. And the first thing we're going to deploy is going to be the storage layer. And I have, this is very small, just a second. I should have, yes, I have here a very basic Helm file, very minimal, from Launchpad Starter. I deleted that sample that has like comments and a lot of stuff. I just renamed it, and starting with a clean one, I think it's easier to follow. We have kind of a header. We set the Kubernetes version. This is useful sometimes. And I'm just going to start by deploying a single Helm file, which will be the storage namespace. And I'm just configuring it to use raw file as features. And we start there and let it install. If you do just task, you get a help or a list of commands. And I'm going to do task releases apply. And it tells me what is going to be affected. It's going to apply three things: OpenEBS and raw file local PV in the storage class. And I'm going to say yes. And hope this works, but it should. Like this was quick. I'm going to use K9S to see that I have a new namespace called storage on the cluster, and there's already some deployments going on. And I'm going to use what's the hotkey? Yes, it's a semicolon to go look at storage classes. And now I have a storage class on my cluster, where instead I have none, which is OpenABS raw file local PV. This one is kind of like host path. For those of you who've used Docker Compose or been using containers, even if not in Kubernetes, you probably used to have like host path. You can just pass a local disk, like directory, to a container and use that as storage. This is reasonably similar. The drawback of using something like that is that you can't put like a bound, a quota, or just say that you want a volume of a fixed size, 20 gigabytes, and you don't want that workload to exceed that. You don't have that kind of control on that system. This just has a very simple difference of creating files that will get the size of the volume you want, and then mount them as if they were like a disk. create a file system in them, and use the loopback interface to present that as a disk for the container to consume. Yeah, that's it. Okay, so now we have the storage class. It's kind of very simple. It is a basic deployment, but I'm going to customize it a bit. On this node, I should have a shell here. Yes, I've installed ZFS, and I have 4 disks, 4 volumes, STA to STD, and I just very simply created a pool. Oh, I don't have that command on the log. I just did ZFS zip pool, I think, ZFS or zip pool, create like basic pool with my disks. In total, it has 95 gigabytes. And I named it zip pool. And now I want to change my deployment to actually install the ZFS driver and use that. So I'm going to come here and I'm going to add a bit of stuff to this setup. I'm going to start by adding the ZFS feature. Okay, so what I'm adding here is toggling on the flag ZFS to add releases that relate to this driver and customizing some values. This wouldn't necessarily be needed. If I delete this, it just installs a storage class for ZFS with default settings. But given it's probably a common use case to want to customize some things on this, I have here as an example how we could go about overriding the default ZFS storage class release, passing some values to it, and personalizing these resources. And while doing so, you can also see that a storage class is just something like this, just few lines, just to find a few parameters. In here, I'm setting a record size, turning on compression, giving it the pool name. This is essential so that the driver knows where to allocate the volumes that the containers will consume. And I'm also doing a second one called 8K instead of 120K, which is a different parameter, smaller record size. You will maybe be interested in customizing this for maximum performance, depending on your workloads and things like that. Just kind of an example. So adding these lines, I've now changed my deployment. And I'm going to use task to do release and supply again, which is it's still going to ask me if I want to do it or not and show me what's going to be changed. So that's fine. Well, it's not actually showing me what's going to be changed. Let me cancel this. I think I should have released this diff. No. I was under the impression I would have a diff here. I think we turned this off for now. We turned this off recently because of an issue.
I think you should, if the release is already installed, you should have a diff. We'll look into it.
Yeah. I'm just going to apply it for now.
But I think because you've added the feature, the ZFS feature, which wasn't included before, so that would be new releases, so those would not show a diff.
Yeah, they're new.
Yeah, yes, so those would not
new
show.
releases. Yeah, that's fine. There's no diff because all the changes are to add stuff. It's changing nothing of the existing one. Yeah, you're right. I was confused. Okay, so I've now applied these changes, and I should have. Yes, now I have 2 new containers up in EBS ZFS local PV controller. And nodes, if I wanted to see the logs, I could come here. This container, this pod has a bunch of different containers. And if I go see my storage classes now, I should have some new ones. I have the raw file, and I have the ZFS local PB compressed 128K. Should have two, I think.
In the storage ingress, there's only one defined, unless you. Oh yeah, you should have.
No, but I have this. I've passed on these values. Yeah. So I'm pretty sure I should have two. Does this need to be a list? Sure. Give me a second. What does it say if I do this now?
Yeah, I don't think it picks up your values. So it's probably the format is slightly wrong.
I'm gonna try a list, but I'm not that confident that's the issue. Oh, I know. I think I know what's wrong. I think. Oh no, not so sure what's wrong. Either way, this was just like to give you an example. We'll make another note to dig a bit deeper on what's going on here. This is supposed to work, I think. We'll delete this one, and we'll carry on with this one. So we'll deploy it. And so now we have our cluster has two storage classes. And pretty much any chart you install that uses storage will allow you to specify what storage class you want to use for your PVC. And the name you set there will batch a storage class, one of the storage classes you have in your cluster. It will determine how the storage for that workload gets allocated. Any questions regarding storage so far? Right, I'm gonna continue to add a few more deployments now that we have storage.
Sorry, Carlos. I think I know what the issue is.
Okay,
I
go ahead.
think you just need to specify these two lines before the values. So do you? Oh, you already have it. The merge values is not in line, and then no. Oh no, that looks.
Yeah, it looks right. Well, dig into it. I'm going to add two more deployments on my Elm files, which will be Postgres operating cell secrets and Ingress. I got it here somewhere. The Ingress namespace. And I think for the base ones, Anna, these are all that we need. We'll leave monitoring for after. You do the Ingress, right?
Yeah.
Okay. So we're leaving Postgres operator and cell secrets as default. Those are utilities. Postgres operator, we've talked about it before, at least with some depth. It's just very useful. It allows you to create databases. Postgres databases with CRDs in a declarative fashion. Cell secrets is kind of a utility thing to help us manage secrets in the cluster. And Ingress namespace is, well, to install a controller for Ingress objects, which Anna will explain in more depth next. This one is the only one that's providing some values, and it's basically telling the controller what's the external IP on the nodes. Other than that, it's very, we're leaving it at default. I'm going to add these workloads and this Launchpad to apply this to my cluster. And it does so namespace by namespace. So that's why it asks several times. I added 3, I think, Postgres operates self secrets and Ingress. So I have a few yeses to tell them. If I edit the resources from K9S, you can see the whole object of a storage class basically looks like this. It's just metadata defining things. It's an API thing. In the local PV one, there's a few parameters. The driver is the one that interprets these parameters, so they're CSI dependent, container storage interface dependent, like ZFS has these parameters. This will be meaningless for raw file. Let's look at our pods. Okay, so something failed here, which our pods already a Postgres operator in sales secrets and ingress controller. What failed here? Third manager because of CRDs. Give me a second.
If I'm not mistaken, I think that happens the first time on a new
Yes,
cluster where there's a race condition between the CRDs. And if you reapply, it should fix it. We should probably. Okay.
I'm gonna try to use Helm file directly to see the behavior. Enter the flag that may help here. Oh no, it's a different issue. I know it's wrong. The CRDs missing really are missing. The problem here is that in default configs, the ingress namespace uses objects used for monitoring, CRDs that pertain to service monitor from the API monitor, monitoring.coreos.com. That's because most of our namespaces by default bring tie to our monitoring stack to provide observability. And with the default set, it tries to install objects which the class doesn't know about yet because the custom resource definition had been installed. So what's missing here is that we need to deploy monitoring first. And since I wasn't interested in monitoring right away, I didn't, but I forgot about this detail of having a dependency or having to customize like Ingress to skip those resources, disable monitoring on it. So I'm just gonna install monitoring first, and that's what's going wrong. It's still gonna error now, probably, until it installs monitoring, even if it fails on Ingress, and then it should work. And this stack brings the monitoring one, brings Loki and the Kubernetes stack, which has an awful lot of features.
I think for Loki, you might need to specify the storage class because it doesn't come with one by default.
Yes, right now I'm just it installs the CRDs regardless, which will unlock maybe being able to deploy Ingress. And then we can adjust the values. Now Cert Manager installs. Okay, then it has taken a while. Do you want to go ahead with Ingress, an Ingress overview? There was some interest in that, and we're already running a bit short on time.
Yes. I can, yeah. I'll reshare my screen.
Let me just stop my.
Okay. Okay. So for Ingress, you've already seen it installed. I just want to quickly, before I go into into like a diagram of how everything works, just want to quickly say that as you've seen it install Cert Manager and Ingress and GNX, you've seen us already do this where the external IP is changed to the node IP to accept inbound traffic. And for Cert Manager, we are adding extra arguments to point to, I don't know how you say this, Acme, HTTP01 solver name servers, and we'll talk about that in a minute. But in terms of what you need to know in terms of how Ingress works, that I should just quickly take you through like a user journey. Say a user makes a request to visit the website. So for this demo, we'll do Grafana, we'll show Grafana. So the URL is grafana.loh.graphops.xyz. And they press that in their browser, and the URL entered by the user will go through some DNS resolution and will translate to the public endpoint of the cluster, which will then make the traffic arrive at the Kubernetes cluster, and then it will be intercepted by the Ingress and GNS service. So this service is already exposed to the outside world with that external IP address you've seen Carlos show, which means it can receive incoming traffic. Then what would happen is that we'll have an Ingress resource evaluation. So the Ingress controller would examine the incoming request to match the host and the path against any rules defined in existing Ingress resources. Right now in our cluster, we haven't defined any Ingress resources, but I'll show you how to do that in a minute. And an Ingress resource is just a set of rules that allow inbound connection to reach your Kubernetes services. So your traffic was matched to an existing valid Ingress resource, which means that now your traffic can be routed to the service in question, so our Grafana service, that would then take the traffic to the actual Grafana pod to the pod that runs the application. At this point, response is sent back. So after the application processes the request, it will send back the response through the same path defined in the ingress resource, completing the request response cycle. Some additional things, you can customize your ingress nginx with the config map. There's a config map that comes with the chart. You can customize that if you want. Our current config map, I can show it to you, but it hasn't been customized. We haven't needed to do that. And this diagram doesn't show anything related to TLS or SSL and how that is configured, but for that, we are using Cert Manager. And just super briefly, what happens, so we said the request goes from the user to the public endpoint to nginx, to the ingress rules. There is something called the cluster issuer that has been deployed by Cert Manager that would watch for new ingress rules and create TLS certificates in the cluster so that traffic is served securely. So, okay. So in terms of some prerequisites that you needed for ingress, it was just kubectl with a Kubernetes cluster. And then in addition to that, you needed to do some a domain with access to DNS settings. So we've created an A record pointing to our node's public IP for this demo. The A record is a wildcard, so wildcard.loh.graphops.xyz, pointing at the IP address, and that's so that we can easily use like hello world.loh.graphops.xyz and grafana.loh.graphops.xyz. Okay. Let's see. In terms of, we've already deployed ingress with the right setting, the external IP, and Cert Manager. The next step would be to deploy applications. So we have an Echo server, and as part of monitoring, Grafana has already been deployed. But to actually expose Grafana and Echo server to the outside world, we would need to deploy ingress resources and then look at certificate issuance and so on. So we'll do that now. Can you see my terminal?
Can you guys just give me 1 minute to add something? If you can go back to the ingress there, because I know there was someone from Pinex that was struggling with ingress now. I just wanted to add something, if you don't mind.
Not at all. Let me... the diagram?
Yes, just because it's more visual. Yes. Okay. So this is all like a whole lot of Kubernetes abstractions, but I think it's a lot more people are familiar with just running an nginx and virtual hosts, where you have a config file where you set, depending on the domain, for instance, you redirect the traffic. So you get like nginx listening on port 80 and port 443, and depending on the domain that the request came to, it redirects it, it forwards it to a different workload, right? That I think is familiar to a whole lot more people. And that's how that it still is in practice. Like what it happens is that you specify those ingresses just an API to specify those parameters, like what's the host name, where it should be redirected to, and then the nginx ingress control just basically takes all those ingresses and generates a config file for its nginx workloads. So it just keeps, you're basically manipulating that nginx config file via creating ingresses and deleting ingresses and changing ingresses. The controller, all it does is taking all those fragments and building a dynamic config file for its nginx instance that it has running. And that config map that Anna references is just like a way to also change the parameters which are not vhost related, like the general nginx process parameters on that very same config file. So all the controller does is taking all of these resources and dynamically generating that config. and it's basically just what's familiar to you guys already, for most of you, I think. But it's manipulated and created this way, which is less abstract. I think under the hood, that's all that's happening. So, okay, sorry. Go on, Anna.
Thank you. That was a great addition. I think Vince had was typing. Still typing. Maybe we'll just quickly wait for his question, comment. But yeah, thank you for that. And I think things will become even more clear when we have a look at the Ingress results as well. So if building out Nginx with Keep Alive, you set a record to VIP that goes to control planes. I'm not sure. Carlos, can you take this one?
Usually, the control planes will be running Kube API, like what's the workload name? The API server, which is what your kubectl must connect to and how you interface with Kubernetes API. But the workloads themselves, you want running on the worker nodes. So you probably have more than one VIP, one for the control plane and one for the cluster from the point of view of worker nodes. So your Nginx is running the daemon set, which just means that it's going to run on all worker nodes so that they all can accept ingresses, no matter which one your request arrives at. They will all be listening on ports like 80 and 543 and taking in the request, for instance. That's a possible setup. Then you want a workload like a VIP that points, or a load balancer that points to your worker nodes and your other workloads. The control plane is just is generally kept separate and doesn't run workloads, and it won't run a Nginx controller on them, like on that daemon set. It will be running Kube API server, the scheduler, the controller manager, DTCD sometimes. It can also be externally TCD if you want, but generally you keep those separate. And it's not even something you want or need to have publicly available, like the control plane node. The control plane nodes make sense to not be publicly exposed. You may, like, say, use a VPN to reach them or something like that. So now I think you also want a load balancer or a VIP, some kind of VIP to your actual worker nodes that will be running your workloads. There is a distinction. Of course, we're using a single node cluster, which obviously everything runs on the same node. And that's also a possible setup, but not what people tend to use in production at all. They tend to separate those concerns and treat it like that.
Yeah, I was just trying to show that the Ingress Nginx controller is running as a daemon set. So basically, yeah, you'd have a pod. So in Ingress, you'd have an Ingress Nginx controller pod running per node, pointing out at the IP of the node itself. It just so happens that our node is also a control plane in this setup. But yeah, just for additional clarifications. Okay. One more thing I wanted to quickly show before demoing. I know we're running out of time, but just for additional. So yeah, we mentioned that we're using Cert Manager, which ensures certificates. It creates automatic certificate, TLS certificate. It does this using issuers. So in our ingress is set with Let's Encrypt staging and Let's Encrypt production issuers. And so it uses issuers in the cluster and certificates, and then Kubernetes secrets for each one of those ingress rules, and you'll see how those are applied in in a moment. So I'm just gonna go ahead and okay. So first thing first, I'm gonna deploy Hello World server, which is an Echo server. I'm doing this using an external repository that is not included in any of our namespaces, so I need to specify it in our helm file here. And I've already written down the release details so that I save time. But yeah, so this will install a Hello World release. I'm having Ingress enabled. I'm adding an annotation for the cluster issuer. So Let's Encrypt Production is the cluster issuer I'll be using. I'm specifying what the TLS host will be. So Hello World, LOH, GraphOps, all of that. This specifying the secret name. This is not the secret I'm creating myself. This is something that a cert manager would create once it sees this ingress resource. And then we're also adding a rule saying this is the path you're going to serve traffic on. So I'm just going to go ahead and do that. So if I run task releases apply, and then our namespace is Hello World. Okay, to do that. Okay, so looking into the cluster, if I search for ingress rules, I think it's just ingress actually. You can see I have a new ingress resource. Based on that, it points to our host, and if I do YAML to describe it, again you can see the rules. So it routes port 80 on this service that sits in front of the application. We have a TLS host and a secret name. If I look at secrets, this would be the secret that cert manager created. I can do YAML. It's just a TLS.cert. So now if I go back to my browser and go to Hello World, LOH, GraphOps, XYZ, I didn't give it a query or a parameter, but let's see what we can do with it. Let's say we give it this. So the Echo server just returns what you gave it. I don't think there's a host. I don't know if this will work. But yeah, it's basically what you're seeing here. So this is the name of the this is the name of the pod. So what you're seeing here is that the request goes to the Echo server. It is connection is secure. You have a valid certificate. The valid certificate will be automatically renewed by cert manager. And let me see if there's any questions. Yeah, so You can do some other things with this echo server, but just you can see that the traffic is working properly. And let's create separately an ingress rule for monitoring for Grafana. Now, this will be slightly different. So the Hello World chart itself, the echo server's chart itself, contained values and logic to create ingress rules within its logic. But the Grafana, the monitoring chart does not contain that. So instead, what we'll do is we'll use our resource injector to add an ingress resource, which is a full, just a full resource, and it looks very similar to the one that was created earlier. So again, we are specifying the cluster issuer, which is let's encrypt production. We are specifying the host, where the service that will be forwarding traffic to the application itself. And yeah, the name of the secret to create. So if we run this, and just to show that this hasn't actually, it's currently not working, let's just quickly do this. So the site can be reached because it's down. So task releases. Because that ingress resource is in the monitoring namespace. Many apologies, Matthew, regarding the calendar mix-up. I think we need to fix the foundation calendar link so that they're on the same page. What is this doing? Okay, sure. I think there's a small mismatch between the Loki distributor ingester stateful stat storage class name that Carlos created and what I have locally, but we don't really care about Loki right now, so I'm just going to apply. Okay, that makes sense. In that case, there's many ways to do this. What I'm just gonna do, just to move forward, is just delete the Loki and recreate it. So delete and monitoring. But I could just update the storage class and all of that. But I'm just trying to move really fast. I'm aware that we've gone a bit over time, so I should be done in the next few minutes. Okay, this is the Grafana ingress resource I've created with the resource injector. And just a reminder, with the resource injector, it's been created so that you can define any resources you can think of. Okay. So again, looking at ingress, We have the Grafana Ingress, and you saw one that was automatically like a config map that was automatically created and managed by Cert Manager. And computed by it. So now if I go here, we are loading Grafana. Okay, you can see dashboards. Like, we've been through this. I won't spend much time on it. You can see, I don't know, Kubernetes API server and stuff. But basically, again, we have connection is secure. The traffic is routed to the right application. I guess one way to break this would be for example, if you didn't add a secret name here, then the traffic would be insecure. Yeah. And that's basically what I had to show for Ingress. I've added some resources in the presentation, so you can read more about Ingress Controller and Cert Manager itself. They are complicated topics with a lot of options, a lot of ways of customizing, but we've tried to make it as easy as possible so that you don't need to do much out of the box. Again, you can feel free to use different solutions like AJ Proxy, Traffic, or whatever suits you best. Do we have any questions? I can see Matthew typing.
It's not out of scope, Matthew. Of course. Well, Cert Manager is hooked up to the Kubernetes API, right? So as long as you create a resource, like the Ingress is gonna prompt creating a resource, it's gonna have a notation that Cert Manager will read and create a resource, which will start triggering the whole flow. It's a complex flow for Cert Manager, so I won't go too much into it. But there will be a need to create a certificate, right? And Cert Manager will take care of that. The only thing it needs is that some nodes, some cluster nodes, will eventually get the request from Let's Encrypt. If you're using that, most people will be using that. Yes, it needs to run at the right cluster. Yes.
Sorry, maybe I'm just misunderstanding the question, but if the question is, okay, so the DNS is shared, but you have two different Kubernetes clusters, wouldn't it be that you deploy Cert Manager in both clusters?
No, I see. No, but you only create the object on one. Like, there's no sync between clusters, right? They have independent state. Though what I would suggest you do is that you use, if you want to use Let's Encrypt, you will use DNS based as well, instead of using like, they can validate you on the domain by receiving the request, right? But they also offer you the option to just put up some text based like codes on it to prove that you own the domain, and then they'll authorize you the certificate. They'll sign the certificate for you. Exactly. You'll need some way to use that. Advantage of going DNS based is that it allows you to also have wildcard DNSs if you set it up. You don't have that without with HTTP requests. They don't do wildcard on those. DNS, yes, based. Well, I think that you will find that I will be surprised there's no provider, like there's no solution for you that someone is using, as CertBot and CertManager are very, very popular. And for most of the DNS providers, they do have API stuff. You have to write the solution to your provider. Well, I can't help you there. If the provider did have standard interfaces, like Bind also has an API, kind of like a stacked one for doing that sort of things, remote updates. I don't think providers tend to expose those, but that would be like the standards universal, the universal standards for doing that. If it also doesn't have that, then you may be out of luck. But it should be something easy to do, like in Python or some scriptable language. It shouldn't be too complex. Or even porting. If you want, we can discuss that a bit. How you'll go to adapt it to Kubernetes.
All right. Any other questions? That was a great question, Matthew. No sorries allowed. And thank you, Carlos, for responding. I haven't decided yet if Canada is worse than UK in terms of saying sorries. I just know I've embraced it, but yeah. All right, we're massively over time. So if there are no more questions or comments, I think we can stop the recording here. I'll just wait for Carlos to finish typing.
Just Matthew, because like you're the only one with a question, and I was trying to like give an overview what my expectation is here in terms of what you'll have to do to adapt it. But to give you like a very concrete example, say CNI, the container network interfaces, also has like a lot of hooks. You can take charge of doing the EPAM management and stuff like that. And if you go look at the interfaces that you need to implement to hook into some part of the system, like run workloads, they even work with like just mvars that get passed around or pipes, literal pipes, like they just, the output of a process gets fed like as the input. They're very shell-like, simple, Unix, very in the spirit of Unix many times. And my assumption here is that the interface you'll find to register a plugin for Cert Manager will also be like a very simple interface. And you have your script, you'll have to run it in a container, and it's going to get some external inputs, either as vars or just like being called like that. And we'll have to, an interface to outputting stuff will be actually outputting to STD out. They tend to be simple things.
And just a quick follow-up before we finish. Just wondering if we don't have any guides for like these customizations and like this kind of session. Just wondering if setting up Ingress and all of that is something people would like to see in the docs, or if the recording of this session would just be enough. All right. Thank you, everyone. In that case, Pili, if the recording is still going, it can be stopped. And